video, we are exploring the ESP-3 or External Storage Platform 3, the 19th module of the International Space Station ISS. Let's start the video. The External Storage Platforms ESPs of the ISS act like storage racks for spare parts, Orbital Replacement Units or ORUs, that keep the station functioning smoothly. Just as spare parts are vital to maintaining high-performance machines, the ISS needs backup systems that can be swapped out quickly during spacewalks or robotic operations. ESPs are positioned outside the station, so astronauts don't have to bring malfunctioning equipment inside the pressurized modules for repairs, making these platforms crucial for ISS operations. The ESP-3 was delivered to the ISS in 2007 and attached to the nadir side of the S3 truss. It's the third in a series of external storage platforms designed to hold critical spare parts like pumps, tanks, control systems, and even spare electronics. What makes ESP-3 unique is that it was the first ESP to be installed using the Canadarm2 robotic arm, without needing a spacewalk for its replacement. This advancement significantly reduced the risks associated with spacewalks and allowed the installation to happen much more efficiently. The ESP-3 holds up to 7 spare parts, including ammonia tanks for cooling, control movement gyroscopes, and various electronic units. The platform provides easy access for both astronauts and robotic systems, ensuring that critical repairs can be made swiftly. In addition to serving as a storage site for spare parts, ESP-3 also supports some power and data connections for equipment it holds. This connectivity allows systems to be checked and maintained, even before they are needed for installation or replacement, ensuring they are fully operational. The External Storage Platform 3 ESP-3 was manufactured by Airbus Space Systems, with contributions from NASA and Boeing. Assembly took place in NASA's Operations and Checkout Building in Goddard Space Flight Center located in Greenbelt, Maryland, USA. ESP-3 is built primarily from steel, with some components anodized for extra durability against harsh space environment. Its design closely mirrors that of ESP-1 and ESP-2, ensuring consistency and compatibility with the ISS's integrated truss structure. Manufactured in 2007, ESP-3 serves as a key component for storing critical spare parts, playing an essential role in ISS's operational longevity. The ESP-3 was launched as part of the Assembly Mission 13A.1, a continuation of STS-117's 13A. As the spatially Endeavour stood on the launch pad, fully fueled and ready for its journey, the crew made their final preparations for the mission. The focus was to carry critical hardware to the International Space Station ISS, including the S5 starboard truss segment and additional spare parts stored in ESP-3 and Space Hub Logistics Module. Countdown proceeded as usual, with the shuttle systems undergoing final checks. At this stage, the crew aboard the shuttle, led by Commander Scott Kelly, reviewed their procedures one last time. External communication channels were clear, with mission control closely monitoring weather and technical conditions. In the minutes before launch, the shuttle's main engines and solid rocket boosters were armed, awaiting ignition. As the countdown reached zero, Endeavour's SRBs, with a brilliant burst of flame, lifting the shuttle off the pad, embarked on its journey to space. As the shuttle soared through the atmosphere, the crew's focus shifted to the mission's objectives, with preparations for rendezvous and docking with the ISS underway. in orbit, on flight day 2 of STS-108, the crew of Endeavour performed routine inspection of the shuttle's heat shield using the robotic arm and the Orbiter Boom Sensor System (OBSS). This was a key check to ensure the shuttle's safety before its rendezvous with the ISS. On flight day 3 of STS-108, the crew executed the rendezvous pitch maneuver (RPM), where the shuttle performed a 1 degree per second backflip 60 feet below the ISS. This allowed the station crew to photograph Endeavour's heat shield for inspection, ensuring there was no damage. Following the RPM, Endeavour successfully docked with the ISS. The installation of ESP-3 was scheduled for later in the mission, with critical preparations underway for its eventual deployment using the shuttle and the station's robotic arms. On flight day 4 of STS-108, the crew installed the starboard 5 truss (S5 truss), which was crucial for expanding ISS. On flight day 5 of STS-108, the crew completed a focus inspection of the shuttle. This led to the official extension of the mission to 14 days. The inspection revealed no significant concerns regarding the shuttle's heat shield, although one area showed deeper gouges that would be analyzed further. NASA planned to conduct thorough reviews of foam loss history and evaluate potential future actions based on the data collected. On flight day 6, astronauts Rick Mustachio and Dave Williams successfully completed the second spacewalk of the mission. They replaced a failed control movement gyroscope (CMG) with a new one, which was installed on the Z1 truss. Although Mustachio experienced a CO2 alarm in his suit, NASA confirmed it was a fake alarm. Meanwhile, discussions continued regarding the shuttle's heat shield, focusing on potential re-entry issues. The crew was prepared for on-orbit repairs if necessary. They successfully installed the external Stowage Platform 3. This installation was notable for being the first ESP module to be installed all by the robotic arms, without the need for an EVA. The shuttle arm retrieved the ESP-3 from the payload bay and handed it over to the Canadarm2, which installed the ESP on the nadir side trunnion pin on the S3 truss segment. After the installation, they also conducted public outreach events. On flight day 8, astronauts Rick Masaccio and Clayton Anderson conducted the mission's third EVA. Successfully relocating a SETA cart. Retrieving the P6 transponder and moving the S-band antenna. A possible tear was discovered in Masaccio's globe, prompting NASA to end the EVA early. The fourth EVA was postponed to at least August 18th, with further analysis of the globe and tile damage on the orbiter plant. Preliminary results from the arc jet testing were encouraging, indicating that repairs might not be necessary. On flight day 11, NASA shortened the fourth EVA to 5 hours due to Hurricane Dean's path. The EVA achieved 3 primary objectives, but 2 tasks were deferred. Astronauts Williams and Anderson had a stunning view of Hurricane Dean from space. Williams set record as a Canadian with the most spacewalks and surpassed Chris Hadfield's total EVA time. A farewell ceremony was held before hatch closure, and plans for undocking were adjusted to avoid potential hurricane evacuations. On flight day 12, Endeavour successfully undocked from the ISS at 11:56 UTC. NASA decided not to conduct the usual fly around, allowing the crew downtime before landing preparations. The crew performed 2 brief firings of the reaction control system to distance from the station and began inspecting the reinforced carbon-to-carbon tiles on the shuttle. The mission management team reported a go for landing on Tuesday, with Hurricane Dean's track becoming more favorable for Houston. Alternate landing sites were also being evaluated. On flight day 13, Endeavour's crew conducted re-entry preparation tests and configured the spacer module for re-entry. They practiced landing approaches using the onboard simulator. Entry flight director Steve Stish confirmed favorable weather for Tuesday at Kennedy Space Center, with backup options at Edwards Air Force Base if necessary. 2 landing opportunities were scheduled, with one requiring a deorbit burn at 15:23 UTC. On flight day 14, Endeavour completed successful deorbit preparations, including closing the spacer modules and donning re-entry suits after a go for the deorbit burn. The shuttle's engines fired for 4 minutes, slowing its speed significantly. The shuttle landed at Kennedy Space Center at 16:32 UTC with minimal thermal style damage observed post-landing. NASA's administrator Michael Griffin confirmed that the ISS was 60% complete following the mission. The ESP-3 Express Logistics Carrier 3 is a crucial part of the ISS, serving as a storage platform for various Orbital Replacement Units (ORUs). Now let's take a deeper look at the parts of the ESP-3. FRAMs. FRAM-1 previously held pitch roll joint number 6 was swapped out during STS-124. FRAM-2 initially hosted a nitrogen tank, now contains a flex hose rotary coupler FHRC added during STS-126. FRAM-3 holds pump module assembly number 2 installed by the STS-127 crew. FRAM-4 consisted of a control movement gyroscope CMG number 2, but it was used during the mission STS-122 to replace a damaged CMG on Z1. And later during STS-127, LDU or linear drive unit was attached. FRAM-5 hosts a space to ground antenna number 2 added during STS-127. FRAM-6 contains battery charge discharge unit number 19 launched along with the ESP-3. FRAM-7 stores flight support equipments FSE added by STS-118 crew. Grapple fixtures. The ESP-3 contains two power data grapple fixtures PDGFs. These fixtures allow the robotic arms to maneuver the ESP-3 during installation and transport within the ISS. Trunnions. The ESP-3 hosts 4 trunnion attachment points. These are structural support points that allow ESP-3 to be securely mounted on the ISS. They facilitate the stability and alignment of the platform during operations. The ESP-3 Express Logistics Carrier 3 measures approximately 8.5 feet 2.6 meters in length and 14 feet 4.3 meters in width. Its mass is around 3,000 pounds, 1,361 kilograms. In conclusion, the ESP-3 is a vital component of the International Space Station, providing essential storage for Orbital Replacement Units (ORUs) and enhancing the station's operational capabilities. Its successful installation and subsequent relocations demonstrate the effectiveness of robotic systems in space. As the ISS continues to evolve, platforms like the ESP-3 play a crucial role in supporting the ongoing missions and advancement in space exploration. I hope this video on the ESP-3 was interesting and informative. I'll meet you in the next video with another interesting module. Take care. Bye.
home.